Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called NYPD by Fill the Hat. And here are the rules. Place all of the digits 1 through 9 in each row, column, and 3 by 3 box, so normal Sudoku rules. We also have non-consecutive rules where no two orthogonally connected cells may contain consecutive digits. That means that basically no two cells that share an edge can be consecutive. So if this were, say, a 5, you know these digits that are next to it, that share an edge with it, cannot be 4 or 6. And that's an example of how non-consecutive works. We also have yin-yang shade, where we need to shade some cells such that all shaded cells form a single orthogonally connected group, and all unshaded cells form a single orthogonally connected group. And no 2x2 region may be fully shaded nor fully unshaded. So this is an example of a yin-yang shading that is correct or valid. This is not, because there's a 2x2 area that is all unshaded. And this is not correct because to get from this cell, actually it's to get from any of these cells to the rest of the unshaded cells, you would have to cross over to the shaded region, right, by going through this shaded region or shaded region here, or you'd have to cross through a corner. If you can cross specifically only through, if you can get from any shaded cell to any other shaded cell just by going through edges, and you can stay within the shaded region, that was what it means to be orthogonally connected, and vice versa with the unshaded cells, right? All the unshaded cells can get to any other unshaded cells just by going through edges and staying within the unshaded region. And this is an example of how yin-yang works. We also have palindromes, where the sequence of values along a gray line reads the same when starting at either end. And then we get to the final part, which is doublers, where the value of any unshaded cell is the digit in that cell. The value of a shaded cell is double the digit in that cell. So, for example, if this were, say, well, this wouldn't quite work, but let's use this cell as an example. If this were, say, a 3, this would have to be a palindrome this way, looking at the values. So the value of this would be, since it's shaded, it would be double, it would be 6. So that would match this. And then you could have 2 and 4 here. And this would be a valid palindrome, because this 3 is doubled in value, so it's 6, so therefore you have a 6 on both ends in value. This 2 is doubled in value, so it would be 4. So if you read the values, it would be 6, 4, 4, 6, looking at the values in either direction. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So the interesting ones are the palindromes that are in the same box, that have components that must be equal in the same box. And of those, these are some and these are some. So there must be essentially a difference between these two. So we're going to mark this green, this yellow, but we don't know if these are going to be different, if these are different ones, right? These could be the same shading. These could be the same shading. So same with these, right? So, what we do, what do we know? So we know these have to be some shading 2 and 2, right? How do we mark that? So this must be split up. These could be exactly the same digits, so that's fine. These have to be split up, so this has to be a different shading, guaranteed. Let's mark those as red. This, it's going to be hard to mark these. Let's mark it essentially, I don't really like that. Let's mark these spots. These spots also. So these two are the same value, but they're different shadings. Same with these. These could be the same cell. This has to be different, so we know this is flat out a difference there. These two could be the same digit. These two could be the same digit. So could these two, so could these two, so could these two, and these two. These two are different digits. These could be the same digit, so that's fine. These have to be different than this, but it could go something like these are the same color and these are the same color. Oh, wait, no. Hold up. That is incorrect. That is incorrect. Okay. So I can remove a lot of the X's. Okay. These have to be different regions because they are essentially next to each other. So this has to be a different shading. This has to be a different shading then also for a similar reason. We know similarly these are a different shading and these are a different shading. This, I'm not sure how to mark that X. But these have to be different shadings because they are the same value, but one has to be doubled and the other one doesn't. Okay. So we have one break here. So in yin yang, you can only have on the edge of the grid 2 swaps in sets. Because if you had more than that, so say we had a swap here, and then a swap here, and then say another swap here. That would mean, how does the blue orthogonally connect to each other while still being in the same one continuous region, while still having the green orthogonally connect to each other and still stay in the same region? You can't. That's why you know along the edge of the grid, you can only have 2 swaps in color total. So we know that this must be double, one of these must be double the other one here. Oh, these sort of act as like Kropke, black Kropke dots in a sense, if you think about it, right? So this has to be double of that, or it's half of that. We don't know which. Therefore, these are double of each other. These are double of each other. These are double of each other. So we know this is 1, 2, 3, 4, 6, and 8. Because one has to be essentially double the value of the other, and the other is essentially doubled, right? So this is 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8. Same here. Oops. Same here. This is similar. It has to be doubled also. 1, 2, 3, 4, 6, 8. This is doubled again of another one. 1, 2, 3, 4, 6, 8. So this has to be a different one there. These two could be the same digit. These two could be the same digit. So could these two and these two and these two and these two. Okay. What does that tell us? I'm not really sure. It tells us something, but I don't know what it is. So this is one switch in boundary. We don't have another guaranteed one anywhere right now. Hmm. Interesting. Okay. Say this is a 579. That means it's guaranteed to be here, and then it would have to be guaranteed to be that cell there. Um, oh, that's interesting. So with these diagonal cross box lines or part palindromes, they force a natural situation where they both have to be the same shading, right? If they are not double of one another. Therefore, the other two cells, one has to be shaded and the other one has to be unshaded if that's the case. Because then otherwise, if they were both the same shading, first you would have, okay, so if you have the same shading here and it's a different shading, okay, well, say it's the same shading. If it's the same shading, obviously it fails the yin yang because it's a 2x2 region that's all the same shading. If it's a different shading, the problem is how do you connect this green region orthogonally to itself as a single region without splitting up the blue region or going vice versa? And the answer is you can't. So these are essentially two very the edge grid thing being only two swaps of shading, and the cross diagonal 2x2 of different shadings not being allowed. Those are very two well common. I mean, just if you think about it logically, like it makes sense, right? How do you come up if you have that cross uh, diagonal? How are you going to make one orthogonal region of the green region while also still maintaining a single orthogonal region of the blue region? And the answer is you can't. Same with the grid, right? If you try to connect the two ends of the blues and then the two ends of the greens together, that won't work because one of them will be split into two regions. So, if this is the same region and this is the same region, what does that mean? Well, at least one of these has to be a 579. Oh. Bingo. Okay. These two must be a pair. So the digit here. Right. Okay. Where is this digit in row 2? It That is crazy. Okay, this digit in row 2 cannot be here. It has to be on one of these three sets, right? And if it's here or here, first of all, well, it could be. What does that mean then? Yeah, so this digit cannot be either of these three cells, obviously. This is either double of that or this is double of that. If it's here, it has okay, so say this was 3 and 6. That's probably an easier way of representing it. If this is a 3-6 pair and one of these are double the other one, the problem is even if this is 3 or 6 here, so if either of these are 3 or 6, Obviously, the other one has to be double the other one, so this can never be 3 or 6, but then we have a problem. So neither of these could be 3 or 6 if that's the case. So if we try to have 3 or 6 here, again, which even if it's not doubled, if it's just a normal 3 or 6, well, it can't be because we know this digit. So whatever this cell is, essentially, if we try to make it here, obviously it can't, or here, if we try to make it either of these two, it has to be double of the other one, or halved of the other one, and either way, this 3 or 6 would essentially be duplicated in row 2, no matter what. If this 3 or 6 is one of these two, if you try to halve or double it, it could only be halve or double. It would be the same as that digit, and they would be in the same box. If you tried to make it the same digit, it would be in that box also. So that doesn't work either. So this can never be a 3-6 pair. It has to be 1, 2, 4, and 8. But that's the tricky part, right? So if it's 1, 2, 4, 8, that means one of these, what you cannot have is you cannot have a 1, 2 here and a 4, 8 here. One of these has to be 3 and 6. We don't know which, though. So the rest of the row cannot ever have 3 or 6. It's 1, 2, 4, 5, 6, 7, 8, 9. No 6. 1, 2, 4, 5, 7, 8, 9. Right? Again, this as a 1, 2, 4, 8 has to be double of one of these two. If it were 8, the problem is, where could that be? So say this was an 8. If this is 8, this has to be with 4 here to be doubled of that. And the problem is, this can't be 8 or 4. This can't be 8 or 4. If this were 8, it would have to be with 4 again, or with 8, and none of those would work. So this cannot be 1 or 8 on the outside. It has to be 2 or 4 on the outside. Now the question is, can this be 2 or 4? I think so. This is definitely a 2 or 4 here. Where can this be? The thing is, it could be here or here. That is possible. Because if that were the case, I think it could be any of these spots. As long as it's 2 or 4, right? If it's 2 or 4, huh. I just thought of another thing. Sorry, I sort of got distracted. But if this is 2 or 4, the thing is, 2 or 4 can be in a 1 to 2 ratio with multiple digit, with another digit, right? So that's why this could be this digit. So say this was here. This digit would have to be different from this. Obviously, it'd be doubled of one or the other. But like, say this was 1, 2 here. This could be 2 and then 4 here, and that would be valid, right? Actually, does that? That's interesting. So these would be different sets, different shadings, obviously, to make that work. Obviously, these would be different shadings, but that's not as connected. This is the more interesting one, right? So these would be the same shading, or sorry, they would be different shadings. And I think these would be the same shading, right? So if you had this as 4 and this was 8 or whatever, and this was 4, this would have to be 2. So you would double 4 and you would double 2. You would have to double 8 and double, or make these essentially singletons. Does that work? Maybe? Yeah, I guess it could. Just go across, right? One thing that is interesting is if this is 579. So actually, I was thinking about this part. What happens if this is 579, 579? Well, the only way that this can't be 57, that same 579, because it sees that cell in the same box. And these are the same value as 579, right? They would have to be. Because if this is the same digit, it can only be the same digit here if it's 579. So if this is 5, that's why I was like thinking about it. If this is 579, this is 579. This has to be 579. It must be the same as that digit then. So this is 579. I mean, that's possible still. What about this? Same here, except that either of these could be 5, 7, or 9, so that's fine. If this is 579, that's 579. It has to be the same one there. But this one could be broader because any of those could be 579. So this could be something like 4, 4, 2, and 8 that way. That's possible. This would be doubled. Oh, that's interesting. No, this would be doubled. And this would be doubled. So it's the same shading arrangement. It's just a matter of where it's going, right? And of course, this could be the similar one, right? So if this is 4 here, and this is 8, then this could be 4 here and 2, right? So you could have a 2-4 pair, 3-6 pair, and then you have, I don't know. This can't be 2-4, this can't be 2-4-8. So it's a 1-5-7-9. This would have to be a 3-6 pair then, if that's the case. That's fine. And then this... Oh, that's interesting. Can you ever have this be 3-6? If this is 3-6, this can't be 3-6, so that forces this to be 3-6. And I think the answer to that is no. So if this is 3-6, obviously this can't be 3-6. Where's a 3-6 in row 2? It must be this pair here. That means this can't be 3-6. Where's 3-6 in row 3? Well, one of them can be here. That's fine. But here, you're never going to have equal sums with here. Right? So that's not going to work there. Same here. 3 and 6 is only can only be doubled or halved to be 3 or 6. And that none of these could be 3 or 6 because of the way row 2 works out. So we know 3, 6 cannot be here. That means this is either... That's interesting. Okay, so this is either... This must contain a 2 or 4 here. So it must be with 1 or 8 here. This cannot be a 2-4 pair. It could be the other 4 or 8, possibly. So we know we have a guaranteed 2 or 4 here. 3 and 6 cannot be here because that forces this not to be 3 or 6. If this is one of 3 or 6. So this cannot... Well, it could be 3 or 6. That's interesting. I think either of these still could be 3 or 6. And then this could still be 3 or 6. Or it could be the other 1, 2, 4, 8. Well, let's say that were the case. So this is 1, 2... This is not 1, 2, 4, 8. This becomes a 1, 2, 4, 8 triplet. That forces this to be 3 or 6. That means this can't be 3 or 6. Where is 3 or 6 in this box? I guess they both could be here, right? And then they could both be here, and that would be valid. Or one could be here. None of them could be here, because 3 and 6 is only in a 1-to-2 ratio, or a single ratio with itself, or 3, or the other 3 or 6. So this could be 3 or 6, and one of these is 3 or 6. Then one of these is 3 or 6, and one of this one's 3 or 6. That's possible. So that's not good restraint there. Obviously, both of these could be 3 or 6 in that case. One thing is that this can never be 3 or 6, right? So it's 1, 2, 4, 5, 7, 8, 9. Obviously, one of them's 5, 7, or 9 at least. This can never be 2 or 4 here. So it's 1, 3, 5, 6, 7, 8, 9 as possibilities. So at least 1, 3, or 6 is here. It could be both, but at least one of the 3 or 6s is here. If it's both, that means this can't be 3, 6 as a pair. One thing. So obviously, out of these 4 cells, 3 of them are 5, 7, 8, and 5, 7, or 9. If you have 2 here and 1 here, this must be 3, 5, 7, and 9s in box 2, which eliminates 5, 7, and 9 in the rest of the box. If there's 2 here and there's 1 here, that means these must be 5, 7, or 9 here. So that means there's 3, 5, 7, or 9s in this box 2 already. So this can never be 5, 7, or 9 here. Therefore, this is one of these at least is 3, 6. The other one could be 1, 8. Or it could be the other 3, 6. That's interesting. Right, so again, if 2 of these are 5, 7, or 9, that means one of these is 5, 7, or 9, so one of these must be 5, 7, or 9. That's 3, 5, 7, or 9s in box 2, in rows 2 and 3. If one of these is 5, 7, or 9, these both have to be 5, 7, or 9, So these two have to be 5, 7, or 9, which means there are 3 5, 7, or 9s in box 2. So this is 1 of 3 or 6, and it could be the others 3, 6, or 1 out of 1 or 8. Interesting. Huh. Um, hmm. So one thing you cannot have is both of these be, well, I guess you could have a 3, 6. No, that doesn't work. So say you had this be 1, 2, 4, 8. Obviously, one of the 3 or 6s in row 1 is here. That would mean that you only have one at most here. So 1's here, 1, 3, 6 is here, 1, 3, 6 is here, 1, 3, 6 has to be here. I guess you could if this is 3, 6. That does kind of work. Then you'd have 3, 6 here. So you'd have to have 3, 6 here, 3, 6 here, because this would be a 3, 6 pair here. Interesting. So this digit, I guess it could be 3. It could be with a different digit. So we're not necessarily removing possibilities of 3, 6. Okay. So this is one split here. Don't know where the next one is. So what happens if these are both 5, 7, 8, 9, or 5, 7, 9s here? Let's see. So this would be the same shading. This would be the same shading. Obviously, these would be different ones. That's interesting. Well, maybe not so much. Does that really give us anything? I'm not really sure. So if this is orange, then this could be, okay, so if this is the same shading, what happens if this is orange? This is orange, this must be orange, so this must be the other one, so we'll say that's pink. This must be the other one, so it's pink. Again, you have a diagonal here that's already orange, so this can't be a diagonal of pink, this must be orange. Oh, interesting. This cannot be pink. If this is pink, that means orange is here. How does this pink orthogonally connect to this pink without breaking this? Oh, the orange could be. It would be a very short pink, right? So the pink would be here. The orange would have to go all the way around here. So assuming this is pink. I mean, I guess this could even be orange, but this would be orange. So that would guarantee that this would all have to be orange, all the outside. Therefore, this would be pink. This would be pink. This would be pink because no 2 by 2 area. This pink has to go out, so these are pink then. This could not be 5, 7, 8, 9. This would have to be at least a pair adding up to sorry, something doubled adding up to another digit. That's interesting. This pink has to go out this way, so that's fine. That's already pink. This seems okay. Not great, but okay. But that's only if this were pink. If this were orange, that would be interesting too. So say this was orange, and then this had to be pink, obviously. Well, this would have to be pink because of the 2x2 area, so that would mean this diagonal could not be orange here, so this is pink. This pink has to go out here. That's fine so far. Hmm. So far, that seems fine. Hmm. Okay. Hmm. 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 Where are these doubles? Okay, so if it's 3, 6, obviously both of these are double, then they're the same here. That's fine. What happens if this is 1, 2, 4, and 8, right? Where could they be? Um, Actually, where are these doubles? I think one of them has to be here, right? So, yeah, say this was 4, and then this had to be 2 and 8. 1 and 2. That would mean this is not 1 and 2. This would be 2 and 8 with that, so this couldn't be 1, 2. Um, this obviously couldn't be 1. 4 could not be any of these. This couldn't be 4. So this cannot be 1 or 2, so this couldn't be 1 here. 1 could be any of these. 1 could be any of these. Um. Hmm. Hmm. So 1, 2 obviously could be the 1, 2 pair here. If that were the case, one of 1 or 2 would be here. The other 1 or 2 would have to be one of these two. So the 1 could never be here then. This would be 1. This would be 2. Okay, so therefore, if this is the 1, 2, if this is the same as this, so whether it's 1, 2, or 4, 8, it has to be one of those two, obviously. So if this is 1, 2, or 4, 8, it could be here. And if that's the case, this has to be the other one. So this has to be one of them. This can, or it could be. I guess it could be 1 and 2 here. Yeah, that's possible. So this could be 1, 2, which means this is not 1, 2. This is then 8. Technically, okay, this can't be 1 or 2. Okay, yeah, so this has to be the 1 or the 8 correspondingly, which means this is 1 and 2. This would have to be a 3, 6 pair. So this couldn't be 3, 6. Where is 3, 6? It would have to be here. So this is 3, 6. This can't be 1, 2. 1, 2, or 8. No, 1, 2, or 8. So one of these is 4, and it would have to be with 2. That seems fine. This can't be a 1, 2 pair then. This can't be 8. So it's 3, 6, or it's 4 and 8 here. That's possible. So one of these is 2 with a 4 here on the outside. 3 and 6 would both have to be here, because one of these would have to be 3 or 6. So that seems fine. 8 could not be here. Possible. What happens if it's not? That's a kind of interesting case, right? So say this was 1. Say we had a 2 here. So say we had 2 here. This could not be a 1, 2 pair, so 1 can't be here. This can't be 2. This becomes a 3, 4, 6, 8 pair. So no 2, 8, 4. This is not 4 or 8. This is 5, 7, 9. So this must be the corresponding 5, 7, 9 here. This can't be 2. So 1 cannot be here because it would be... I guess 1 could be here as long as this is 1. That is also possible. This can't be 2, so this can't be 1, 2. So this is either 3, 6, 3, 6, which makes that 8. Or this is 8 and 4, which means this can't be 8 either way. So this can't be 2 or 8. So this can't be 1 here. This is a 3, 6, 8 triplet, which means this can't be 3, 6, or 8. That's fine. So it could be a 1, 1 pair here. Or 1, 1 being here. That seems fine. It would just be that these are the same shading and these are the same shading. But again, we didn't run into any major problems with that being the case. Huh. Hmm. That seems fine. Um, I think we have to figure out more of the shading then. Um, so these are obviously different shadings. Right. If this is the same four, the thing is that. Hmm. Where are these two digits here? Obviously can't be these. At least one of these. So in box 3, well, if it's 3 6, it's obvious what that is, right? If this is a 3 6 pair, this has to be 3 6, and both of these are 3 6. So that's trivial. But what if it's 1 2 4 8? Does it have to be the same two? I don't think so, right? Hmm. No, it doesn't seem like it has to be. Oh, and in fact, it can't be. So if this is 1 2 4, oh, it could be. If these are both, yeah, that's why the 1 8 is there. Oh, that's right. But it can't be 2 and 4. So I think that's one thing we can rule out, right? If this is 2 and 4, this can't be 2 and 4 here. Um, but this could be 2 4, and then this could be 2 4. One of these is 2 4, and then you will have one of those, one of these three as 2 4, right? As the other 2 4. It could be even just even same as that digit. So that's pretty wide. We don't have any restrictions coming from that right there. I guess I have, yeah, I think I have to do the shading thing and try to understand how the shading affects things. Ugh, ugh, this is kind of painful. Anyways, so we have to go back to this. If this is orange, this obviously if this is orange, this must be orange because it can't be different shading. So this is a pink. Pink must go out. This is pink. This must be orange. Um, so again, what happens if this is 5 7 9 5 7 9? So that's kind of what I was aiming for there. So if this is 5 7 9 here, this is the same digit here because it cannot be double of another digit. So it must be the same digit, either the both double or the both the same. These cannot be the same. This cannot be the same digit because even if it were the same digit, it would have to be with its same digit on the palindrome, and that would fail. So this would have to be 5 7 9. So these would all be the same. So this would also be 5 7 9 here. So these would be the same digit, guaranteed. But the question is, what about the shading? Obviously, these shadings would have to be the same. But we're not guaranteed that this has to be the same shading as this. That's the problem. And I didn't really want to go down this path. Well, okay. Where can 579 be here? Oh, that's interesting. Well, it can't be here. Can't be here, can't be here. So that it can't be here. So it's one of these two. So if it's here, it would have to be here, which is not valid because you already have that in that row. So it would have to be here, which forces that to be here. So it must be the same as that. That's fine. That means one of these is orange. One of these is orange. And one of these is orange. So that doesn't restrict anything. Yeah. That was the only one that was majorly restrictive. I didn't see any other ones. Really, because like the problem with this and this is that we aren't guaranteed. Well, I mean, obviously we're guaranteed one here. And then I guess it would have to be here. That's interesting. Kind of. So what happens if this is a 579? If that's 579, that's 579. None of these could be 579, so it's one of these two. Which means it's one of these three, but it can't be that one, so it's one of those two. It also must be one of these three. Cannot be this one, because then this would have to be the same digit. So it could be that one? Possibly. Same with this. Oh, if one of these is 579 and this is 579, you have the same kind of dilemma, right? So orange would have to be here. Which means this could not be orange. So this would actually be an orange-blue pair. This would be an orange-blue pair. Orange would have to be one of... It could be these three. So that could actually work there. So that's fine. Well, where would the other blue-green be? Oh. Yeah, since this is blue-green, it would have to be... The other one would have to be there. Say this was blue, though. That means this is blue, so neither of these could be blue. Therefore, they would both be orange. This would be blue. That seems fine. One of these would be blue, but not that one. So it could be one of those two would be blue. That's no good. Not helpful. Not restrictive. Obviously, if this is 579, it could match one of these two. It could be either one. If this is 579, it could be either of these two. That's fine. 3-6 seemed fine also. So we know of these, at least one of these is a 579. Of these four, at least one is a 579. Of these four, at least one is a 579. You could have up to three. So you have to have like a double digit somewhere. Sorry, a doubling of the digit somewhere. This is three, so all of these could technically be 579. No, well, yes, you could. This could be 579, 579, 579. And then this would be the 579 that's missing here. This 579 would have to be the 579 there. Hmm. So this is definitely not 579. What happens if we assume these are all the same digit, right? If you have the palindrome line, let's assume you had the same digit everywhere else. Is that possible? I don't really know. Let's try. Orange, blue, yellow. This is obviously yellow. This would then be blue and orange. This couldn't be blue or orange. I guess we could make it gray. Could not be yellow either. This has to be different. These two are different than these two. But this could be blue here, or something along those lines, right? Seems okay, right? It's not that restrictive. Because you can always have that, right? It's more of the shading is trying to figure out the where you have to have the doubling. But right now, I'm not getting that anywhere, right? Fairly well. How about here? Well, That doesn't seem to be going down a good path either. Maybe these, what if they're different shadings? Or say these were the same shading. So if this is the same shading, and this then has to be the same shading guaranteed. So this must be green, this must be pink. That means we don't have necessarily have a guarantee this is the same shading because we don't know if these are the same. So that looks okay. What happens if these are the same shading? Pink, this obviously has to be orange and orange. That seems fine. This is pink. What if the, yeah, maybe go back down this path. Orange, orange. This is pink, this is orange, this is pink. And we made this orange, this is pink. This has to be pink, so this is pink here. Yeah, let's go back to the 579. Maybe that will be helpful. Instructive, maybe. These are the same digit. These are the same coloring. Assume this was also the same coloring, so this would be pink then. This would have to be orange. This would be pink. And we're assuming this was orange, so then this would be pink here. Actually, what happens if we assume this is pink? Then, well, we knew this was orange. This would have to be orange here, so this would be a very short pink, so this would have to be orange. Since that would be orange, we know this has to be orange. This has to go out, so this would be pink. This would be pink. Pink here, pink here. So far that's okay. This has to be, well, we don't know. Can't be here, can't be here, can't be here, so it must be here. So this is 579, this is 579, and they're the same coloring. Guess we'll make it yellow. This then must be a 1, 2, 3, 4, 6, 8, right? Because they are one's double the other. Okay, so because of that, well, that's not true. Never mind. I was thinking that this guarantees that, but we don't. We assumed this was, first we made that assumption this was orange, the same shading, and then we assumed that this was the same shading. There's a lot of assumptions being made here. Say this was orange, not pink. Say this was orange, this was pink, then this would have to be orange. So the pink would have to get out this way, which would force this to be pink because it has to go there. We don't have any. I don't think that gives us very much. And that's just like, that's one of the most restrictive ones. Okay, well, I'm gonna go to the bathroom and get something to drink because I'm getting a little thirsty, actually. I'll be right back. Okay, I'm back. I brought some water so I can stay hydrated. I think I was getting a little dehydrated there. Anyways, let's continue. Okay. So what happens if these are different? Well, we assume that this was 4, right? So let's make that assumption similarly. So say that's 4 and 4. This is then 2 or 8. This is then 2 or 8. That eliminates 2 and 8 and the rest. Oh, that's interesting. So this must be a 1, 2 pair here. So this cannot be 1. It can't be 3, 6. This can't be 4. So this must be a 3, 6 pair here. This can't be 3 or 6 or 4, 8, so it's 1, 2. We have a 1, 2, 1, 2 pair, therefore that forces this to be 8. That forces this to be 2. So this would be shaded, unshaded, shaded, unshaded. Well, since these are both... No, that's not right. This, that's not right. This would be shaded. Shaded is doubled. This is unshaded. This is shaded, and this is unshaded. So that's, yeah, that's fine. Okay, that makes more sense. This can't be 1 or 4. No 4, no 4, no 8. This has to be 5, 7, 9. So this must be a 1, which makes this 2. Interesting. So 3, 6, this would have to be a 3, 6 pair here. Because it couldn't be 3 or 8. Sorry, it could be 4 or 8. Because the 3, 6 pair here, where can it be in row 3? Can't be here, can't be here. One of them has to be this, so that must be part of the doublet. This is 4. This is not doubled, so this is green, which makes this doubled. So these are across, therefore this is doubled here. This can, well, it could be green as long as all of this is blue. Huh. These must be the same shading. So this can't be 1, 2, or 8. This can't be then 1. Can't be 2 or 4. So this is 3, 6 with 8, or 3, 3, 4, or 3 and 6 together, or it's 4 and 8. We don't know. Let's say this was green. If this was green, that means this is 2 and this is 1. This would be blue. So this would be blue all the way around. I don't think it's going to work out very well. Therefore, this is doubled, so this is 1, this is 2. This is doubled, so this is 3, this is 6. This is green then. Okay. One of these is 8, the other one's 5, 7, 9. That means this is 5, 7, or 9 here. We have 5, 7, 9 with 8 here. So far, that's fine. That means this is 4, 5, 7, 8, or 9. So far, it seems okay. This then has to be double of the other one. Well, it doesn't have to. It could be the same as long as it's 2 or 4. Or the 8, possibly. Hmm. I mean, that seems fine. Hmm. So if this is both green, this would have to be blue. That's fine. Therefore, that would make that green. If these are both blue, that would mean this has to be green, and this would be blue. Okay, so let me double check. Green, green means this is blue and this is green, right? So green, green. Oh, this has to be green. We know that for certain. This is green. This is green. So green, green means this is blue because of the 2 by 2 area, and therefore this is green because of the diagonal stuff. So green, green means this is green. Blue, blue means this has to be green. So this is blue, which would make that green. So blue, blue forces this to be blue. So this is the same color then as this. This is going to be the opposite color. And therefore this must be the opposite color too to match. Maybe we'll make it yellow. Okay. Hmm. I think I'm just not understanding how the shading works with the palindromes. I'm trying to. I'm trying to just trial and error things because otherwise I was gonna be stuck, essentially. Um hmm. I mean, this seems like it works. That's the problem. It doesn't seem restrictive. So I'm trying to figure out where the restrictions are. So far, I'm not coming up with any. Hmm. Hmm. Obviously, there has to be some sets which are not going to be as. I mean, that have to be. Well, they don't have to be double, but they have to be of the doubled set, right? There's only so many 5, 7, and 9s in the pool. If this is 4 and 2, that's one thing that I kind of wanted to test also. If this is 4 and 2, that forces this to be 1, 2. This can't be 1 here. This cannot be 1 and 2 here. This can't be 4. It's a 3, 6, 8 triplet. That means this can't be 2, 4, 8. No, 2, 4, 8. This can't be 2. No 1 and 2 here. This can't be 4. So and this can't be 1 because it can't be 4 doubled or 4 halved. So this is definitely 5, 7, 9. So these are the same 1. This can't be 2, so this can't be 1 here. We have a 3, 4, 6, 8 triplet. 2 has to be one of these 3. But we don't know. Okay, so this would be shaded because it would be doubled. This would be green. This couldn't be 8 here because that would have to be with 4 doubled. If this is 3, 6, this must be an 8. If this is 8, obviously this is 8. Can this ever be 8? That would be 3, 6, 3, 6, 3, 6. So this would not be 8. So this would be guaranteed to be 3 or 6 here. Since this can't be 4, this can't be 2, so this couldn't be 1 here. Hmm. Hmm. Um, what happens if these are both green or if they're both blue? Say they're both blue. Hmm. That's interesting. Oh, that's a pretty important point. Non-consecutive. No two orthogonally connected cells may contain consecutive digits. Oh, you can't have 1, 2. That is a very big detail. No wonder I was banging my head against this. This is very okay. Well, that simplifies a lot. This can't be 1, 2, so this must be 4, 8. Okay, well, that makes that simple. No two orthogonally connected cells may contain consecutive digits. This has to be a 4, 8 pair, which means this is 4, 8. This cannot be 4, 8. You can't have 1, 2 next to each other. So this can't be 1, 2. 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 It's a 3, 4, 6, 8 triplet. This is 4, 8, so this can't be 4. This is 2. That means this can't be 2. This could be 1 or 4. This can't be 1, 2, so it's 3, 6. This can't be 3, 6, so it's 4, 8. This can't be 4, 8, so it's 3, 6. There we go. This must be a 3, 6 pair here. Oh, man, that made things so much easier. This can't be 3 because it's not consecutive, so this is 6, this is 3. Oh, geez, that made things so much easier. This can't be 3 and 6. This is a 4, 8 pair. This can't be 4, so this is 1. So this must be double the other. So this is blue, this is green. Ah, that made things so much easier. Oh my god. And I don't even know. Well, this can't be 1, this can't be 1 or 2 or 4, 8. No, 4, 8. So these are 2, 5, 7, 9s. This can't be 1, 4, or 8. No, 1, 4, 8. So it's 2, 5, 7, 9. One of these is a 2. So it cannot be with 1, so 4 has to be one of these two. To be double of 2. Okay, that makes things a lot easier. Anyways, um, this can't be 8. This can't be 8. So this must be an 8 here. This can't be 1. This can't be 2. One of these is a 4. That 8 makes this a 4. So this cannot be a 4, 8 pair. This has to be 3, and this must be 6. So this is double, and this is half. This is doubled, and this is halved. Okay. One of these is doubled, and the other one's halved. Wow, that made things a lot quicker for this first part. Okay, anyways. Where is the... Well, we don't know. We have 4 and 8. Okay. The remaining digits in row 1 are 1, 5, 7, 9. Okay. This is 1, 2, 5, 7, 9. The remaining digits in column 5 have to be 2, 5, 7, 9. 2, 5, 7, 9. That means this is 5, 7, 9. It cannot be, it could be 2 or 1. Okay. Non-consecutive. 8 cannot be consecutive with 7 or 9, so this has to be a 5, 4, 5 pair. So these can't be 5. This is a 7, 9 pair. That forces this to be a 2, 5 pair. Interesting. So can remove that. This can't be 5 because of the 4, 5 pair. The remaining digits are 1, 2, 7, and 9. Okay. Interesting. Man, I was stuck on that for so long. And then the reason was because I wasn't using one of the rules. No wonder it was so difficult. I was like, this is really hard. It's like, oh, I forgot about the non-consecutive part. Oops. Um, hmm. What else do we have here? This is 3, so this cannot be consecutive with 2. So this can't be 2, this can't be 2, this can't be 2. 2 has to be one of these two. So this must be a 5, 7, 9, and these are the same. How do you say it? These are the same. These must be the same shading. So this cannot be the same shading because otherwise it would be a 2 by 2 area if they're all shaded, or if this is green, you get in the deadly pattern here. So this must be green. Okay. So if this is 1, 2, 7, or 9. If it's 7 or 9, it has to be 7 or 9 here. If it's 1 or 2, it could be with 1 or 2 here. 1 cannot be here, because if 1 is here, there's a 2 guaranteed to be some in either of these cells. So it would be consecutive with it. So this cannot be 1. No. Yes, 1. No. 2 could be here, too. Never mind. Never mind. This is 1, 2, 7, 9. Cannot be 4, because double of 2 would be 4, but that can't be 4 here. 2 cannot be here, so 2 has to be here, which means 1 has to be one of these two, because if 1 were one of these, it would be consecutive with 2. So 2 is here, 1 is here. We have 5, 7, 8, and 9 remaining of the remaining digits. Okay, 3 has to be one of these digits. 6 has to be one of these. 4 we don't know. If this is 2. Okay, that's interesting. So if this is 2, that makes this not 3. Okay, wait, no, that's the one that's less restrictive. What if this, okay, so say this is, well, yeah, this is 2, this is 5. Oh, that's interesting. So if this is 5, that makes this 5. That means this can't be 6, so this is 3. This can't be 4, so this is 8. So that makes this that pair. That makes this 2, so this can't be 3. That's 6, this is 3. So the shading would have to go, this is blue, this is blue, this is 4. So the 3 and the 4 are doubled. The 2 has to be doubled. The 3 has to be doubled. So we have double here and double here. This is green, so that means all of these must be blue in between. Interesting. So that would force this to be green. These are green. This is green. This is green. And this is green. Okay. These are the same shading, so this must be green. Because otherwise, if this is blue, that can't be blue. If these are both green, this can't be blue. So either way, this is green. Hmm. 2, 4. Well, so far this is fine. Oh, these split. So this must be green and this must be blue. So we don't know where it splits here. Therefore, this is the digit by itself, and this is doubled. So that's 4, this is 8. These can't be 2. This is 179. It could be with 1279 here. We have the deadly pattern. And so this can't be 5. That's what that proves. Unless, can that be blue? No, because then you would split twice, right? So yeah, this has to be green. And we have contradiction. So this can never be 5. Therefore, this is 2. This is 4. This is 5. So this is doubled. This is the same digit. These have to be the same. So these are 5 and 5. Therefore, 2 must be one of these. Therefore, this cannot be 1 because that would split the 2's in one of these two areas, and they would be consecutive. This can't be 3, so this is 6. This is 3. This can't be 4 then because of the 3, so this is 8 and 4. Obviously, this can't be 2 here. The 3 is doubled, and the 4 is doubled. The 8 has to be singleton. Oh, we have a deadly pattern here. Wait. What the... Okay, what bad assumption did I make? Well, this is just obviously a bad pattern. So if this is 2, this can't be 3. This is 6. That makes this 3. This can't be 4 because it would be consecutive with it, so it's 8 and 4. Therefore, this is 4 and doubled here. This is a green. This is green. This is doubled. This is doubled, and this is green, but then we have that deadly pattern. So the 2 cannot be here. So this has to be 5 then. That makes that 5. This is 2. Okay, so then how did we screw that up then? I don't know. Let's try. So this is doubled. This is green. 2 can't be next to 3, so this is 6. This is 3. That means this is green. This is blue. So this cannot be green. This has to be green here, which makes that 8. This is 4 and is blue. Wait, we have the deadly pattern here too. What's going on? Okay, this non-consecutiveness is throwing me for a loop now. Okay, let's reset the mental. Let's get a clean sheet. We know there has to be a 1-to-2 ratio here and a 1-to-2 ratio here. And a 1-to-2 ratio here. You cannot have consecutive ones, so this must be 3, 6, or 4, 8, because 1 and 2 is not allowed. We also know, same here, this is restricted, this is restricted. So, this is 3, 4, 6, 8 here. 3, 4, 6, 8, 3, 4, 6, 8. This must be 3, 4, 6, 8, 3, 4, 6, 8, 3, 4, 6, 8, 3, 4, 6, 8. Therefore, the remaining digits here are 1, 2, 5, 7, 9. This is obviously double of that or halved of that. So this is 1 or 2. This must be 1, 2, or 4. This is either double of that. So 1, 2, 4, 5, 7, or it's the same. 1, 2, 4, 5, 7, 9. This cannot be 3, 6 because of what we've... this is also the same. 3, 4, 6, 8. Right? 3, 4, 6, and 8. Maybe it was assuming that this had to be 4? No, because, yeah... It could be 2 and 1 here. Maybe that was a mistake. I'll have to see. Yeah, maybe that was the error. Huh. This has to be 1, 2, 5, 7, 9. 1, 2, 5, 7, 9. This is also 1, 2, 5, 7, 9. 1, 2, 5, 7, 9. Well, that leaves this as a 4. So this has to be a 4 here. Which means this cannot be 4 here. This can't be a 4-8 pair, so it must be 3 and 6. That means this can't be 3, 6. That's 4, 8. This can't be 4, 8. That's 3, 6. This can't be 3, 6. It's 4, 8. That eliminates 4 here. We have a 1, 2 pair in box 5. Maybe this was... No. Yeah. This can't be 1, 2. This can't be 1, 2. No 1, 2. No 1, 2. This can't be 3, 4, or 6. So this is 8. This is 4. This is doubled. This is undoubled. 8 cannot be consecutive with 7 or 9. So this is a 4, 5 pair, which eliminates 4 and 5 in the rest of the box and the row. This is a 7, 9 pair. This is 3, 6. This can't be 4 or 8. So this is 3 or 6 also, to be with 3 or 6. How did I get this being 6? Maybe that was the problem. I don't know. This is 4 or 5. It has to be with 2 or 5. So this is also 2 or 5. Yeah, maybe it was this. How did I... No, this is a 2, 5, 2, 5 pair. So this is 1. This is 1. This is 2. The 1 is doubled. The 2 is not doubled. Okay. If this is 2, this can't be 3 because they would be consecutive. So this is 6, this is 3. 3 can't be consecutive with 4, so this would be 8 and 4. The 2 would have to be with 4 here. So the 2 would be doubled, the 3 would be doubled, and the 4 would be doubled, and 8 and 6 would be not. And then we have this deadly pattern. So that's not good. If this is 2, this is 4. This can't be 3, this is 6 and 3. This is doubled. This cannot be green, because if they're green, they would switch here, and that's blue. This is doubled. This is not doubled. This cannot be blue, because then you would swap to green, and then you'd have the blue trying to connect to its own region. So this must be green, which makes this 8. This is 4. Oh, I messed this up. No, you have the deadly pattern again. What the heck? What's going on? This can't be... Okay, well now I'm just... I don't know what's going on now. So I did everything from the beginning, and now realizing that there's no two orthogonally connected cells can contain consecutive digits. But that restricts things a lot. But we get this deadly pattern of this green having to essentially... What is going on? What is going on? Oh, okay. 3, 4, 6 cannot be 1 and 2 consecutive with each other, and this has to be a 1 to 2 ratio. So one of them has to be doubled. The other. Same here. 3, 4, 6, 8. 3, 4, 6, 8. 3, 4, 6, 8 here. For all the ones that are in the same row or box, right? Well, these are on the same row. These are the same row. These are the same row. These are the same row. Sorry, the same row or column have to be 3, 4, 6, 8. The other ones don't. So this is 1 or 2. This is 1 or 2 because one must be double the other. That leaves this as 1, 2, 5, 7, 9. But these can't be 1 or 2 because of the 1, 2 pair. Right, this can't, well... This can't be, this is 1 or 2. This has to be 1, 2, or 4. To be double of that. This, again, it could be the same values, 1, 2, 5, 7, 9, or any of those doubled, or halved. Well, this can only be 4 then, 1, 2, 4, 5, 7, 9, but it can't be 1, 2. The rest of box 1 has to be 1, 2, 5, 7, 9. The rest of box 3 has to be 1, 2, 5, 7, 9. Three of these are 3, 4, 6, and 8. Only one of these can be something else. Can be also with that. And it's this 4. So this has to be 4. Since this has to be 4, this can't be 4. It becomes a 1, 2 pair. I guess I shouldn't have eliminated that. Okay, so this could be... It's still, the problem is... Yeah, we have a 1, 2... Okay. The problem is we have a 1, 2, 4, 5, 7, 9 sextuplet in row 3. That eliminates 1, 2, 4, 5, 9, 7, 8, 7, 9 in the rest of the row. So this can't be 4. This can't be 4. To have a 1 to 2 ratio here, this must be 3 and 6. Therefore, this can't be 3, 6 here. This is 4 and 8. This 3, 6 eliminates 3 and 6 here, so that's 8. This is 4. Where is the 4 in row 3? It must be one of these cells. So this can't be 4. Therefore, this is a 1, 2 pair, which eliminates 1 and 2 in the rest of the box. This is then 3, 6, because we have a 4, 5, 7, 8, 9, 4, 5, 7, 9 quadruplet. This 4, 8 pair eliminates 4, 8 here, so it's 3, 6, which means this can't be 3, 6. This is 4, 8. 4 can only be with 2 as the doubled. So, and 7 and 9, it's the problem of the 7 and 9, right? 7 and 9 cannot be consecutive with 8. And this is guaranteed to be 8. So this has to be a 4, 5 pair. That means this must be 2 and 5 to have the same value as the 4 and 5, right? 5 doubled would be 10. 5 halved would be 2.5. So this has to be with 5 if that's the case. 4 could be halved to 2. So this is 2, 5, 2, 5, which means this can't be 2. This is 1. This is 2. These can't be 5. This is a 7, 9 pair. This can't be 4 and 8. So this is a 3, 6 pair here. And then we still have the same problem. This becomes, if this is 2... These are boundaries, right? If this is 2, this cannot be 3, therefore this is 6. This makes this 3. 3 can't be consecutive with 4, therefore it's 8. Therefore this is 4. The 2 would have to be with the 4 in value to be a palindrome. So 2 is doubled, 3 is doubled, and 4 is doubled, whereas 8 and 6 stay the same. The problem is we have this deadly pattern here, where this blue region has to be orthogonally connected, and so does the green region, so that fails. So this cannot be 2, but then if we try it on this side, we have the same freaking problem. Oh! Okay, I see what the problem is. It's not 3, okay. I messed that up. Okay, well, that's obvious then. There we go. That was the obvious thing I was missing. It could be 2 and 4. So we've just shown that 2 and 1 does not work here. These have to be a 2, 3, 4, 6, 8 possibilities. And we showed... what does that mean? One of these is 3, 6. So 3, 6 cannot be this, or this. This is 2, 3, 4, 6, 8. I just eliminated the, yeah. The 2 can be with a 4 in the 1 to 2 ratio, and that's where I missed. Okay, so we know 3 and 6 have to be here, and 4 has to be here. We don't know about 2 and 8. So the rest of box 1 can be 1, 2, 5, 7, 8, 9. 1, 2, 5, 7, 8, 9. And 1, 2, 5, 7, 8, 9. Well, to be with 1, 2, 5, 7, 8, 9, it's the same sets, right? Except, so you could have 1, 2, 4, 5, 7, 8, 9. But you cannot have 3 or 6. Where are the 3 and 6 in row 3? If this is 3 and 6, this can never be a 3, 6 pair, but then 3, 6 can never appear in the rest of row 3, so that's not allowed. So this must be the 3, 6 pair. Since this is 3, 6, this can't be 3 and 6. This has to have a 4, and it's 4 with 2 or 4 with 8. This can't be 4. This has to be a 3, 6 pair. This can't be 3 or 6. It's 4 with 2 or 8 here. Therefore, the remaining digits in row 2 are 1, 2, 5, 7, 8, 9. Again, this can only be 1, 2, or 8 to be double of another digit or halved of another digit. This can never be 4 because of one of these is a 4. So this cannot be 8 here. This is 1, 2, 1, 2. That gives you a 1, 2, 1, 2 pair in that box. This can't be 3 or 6. This is 8 or 4 here. And I'm guessing then... So if we try to make this 4, 8, the problem is we run into the same problem, right? If this is 4, 8, that can't work. So this must be 2 and 4 then. Which means this can't be 2. This is 1. That makes this 2. This can't be 2. So this has to be a 4, 8 pair here. Right? Because we're not guaranteed if this is 2... Well, if this is 4, 8... That's not true, actually. Okay, this can never be 2 here. We know that for certain. Right, because this does have to be a 1, 2, 1, 2 pair. Because you don't have 4. 4 cannot be here, and 4 cannot be here. 4 has to be one of these 3. So since this is 4, this cannot be 3 or 6. That means 4 cannot be here. But 4 could be here. So this can't be 2 or 8. Okay, so we have that. These are all separate boundaries. This can never be 2, and this can never be 2. We've proven that, right? We've shown that if this is 2, well, let's draw a line here. If this is 2, this cannot be 3, this is 6, so that forces this to be 3. This can't be 4, so this has to be 8. And therefore, these would all be doubled, and these would be, so these would all be blue, these would all be green, we'd have deadly pattern. So this cannot be 2, and this cannot be 2. Well, we don't know if this is 1 or 2, or this is 1 or 2. This must be a 3-6 pair. Okay. So 4 can never be either of these cells. Oh, it could be with the 8. Never mind. It could be with the 8. 8 then, so... 4 is one of these 3 cells. Huh. What does that mean? I am not sure. What digits can this be? 1, 2, 4, 5, 7, 8, 9. Okay. We know 2 can't be either of these. If we have 4, 8 here, that guarantees this is 2. Huh. But we didn't try the other way. Does that even work, though? Well, 1... Yeah, there we go. 1 can never be here now. Because 1, doubled even, is only 2. And 2 can never be here because of the 1-2 pair. So we know this is a 1. This is 2. This can't be 2 here, so this is a 4-8 pair. That eliminates 4 and 8 in the rest of the box. So this is 5, 7, or 9. That means this must be a 2-4 pair. That eliminates 2 and 4 in the rest of the box. So 8's one of these 2, or 8 could be here. This is both consecutive with that digit, 3 here. So it's not 3. This has to be 6. That makes this 3. 3 cannot be consecutive with 4, so this can't be 4. Therefore, that makes this 4. So 4 would be with 2 and 8. 3 has to be doubled, so it's blue. Green is here. These have to be the same set, so this cannot be blue. Because then you'd have, if you have blue here, this would be blue, and that's 4 blues in a 2x2 area. If it's green here, you'd have the deadly pattern, which we obviously ran into, so this is green. These have to be the same. But we don't know anything about these. Okay, that's fine. This is a 4-8 pair here. 2 cannot be consecutive with 3. That's the reason why. That's why this is 6. This is 3. This cannot be 6, so this can't be 3 here. So this is 4, 6, this is 2, 3, or 8. This is 4. This is doubled. So this is blue. This is green. So it swaps here. We don't know about this part, though. 6 cannot be consecutive with 5 or 7, so this can't be 5 or 7. We don't... Okay, this can't be 2. Therefore, 2 has to be one of these 3 digits. So if 1 were here, it would be consecutive with the 2 guaranteed. So this can't be 1. Okay. We don't know anything about this. Technically, it could be all green all the way around. um, maybe not. Okay, so if this is 3, obviously this can't be 4. But 6 and 8 are fine too. 6. 5 cannot be either of these because they would be consecutive with 4. So 5 must be one of these two. So this can't be 5. This can't be 5. These are the same set. 8. If this were 8, it would be guaranteed consecutive with a 7 or 9. So this cannot be 8. Therefore, 8 has to be one of these two. Or one of these two. If this were 5, that would guarantee that 8 would be consecutive with a 7 or 9. So this cannot be 5 here. Which means this is a 7-9 pair, which eliminates 7, 9 in the rest of the row. This can't be 7 or 9. This must be 8, which makes this 8. That makes this 5. 8 cannot be here. 8 cannot be here. These are the same shading, but we don't know which. I guess we'll mark it as red. These are the same shading. We don't know which. We don't know what this shading is either. This is 8. 8 cannot be consecutive with 7 or 9, so this can't be 7 or 9. 5, 7, 9, 7, 9. This can't be 8 because it would be consecutive with 7 or 9. So this is 4, this is 8. 4 is doubled, so this is blue. Interesting. And this is green. So all the rest does have to be green. Interesting. That means this is all green. So the reds have to be blue here. This must be blue. This is blue. This is blue. This is blue. So this must be 3, and this must be 6. So 3 is doubled. We have a blue across here, so this can't be green. Therefore, this is blue. So the blue is doubled, which makes this an 8. So this cannot be 8 here. We have 8 and 6 here. This is doubled, so this must be 2. This must be 4. 2 cannot be next to 1, so this can't be 1. 4 can't be next to 5. 6 can't be next to 5 or 7. So 7 has to be one of these two. 8 cannot be next to 9, so this is 1. None of these can be 1 here. 3 can't be next to 2. This 1 eliminates 1 here, so it's 5. This can't be 5. This can't be 1. This is a 7-9 pair, which eliminates 7, 9 in the rest of the box, so this is 1. Okay. Man, that non-consecutive thing is very important. Anyways. Okay. This has to go out here, so this must be blue. Therefore, this 2x2 area can't be all blue. This is green. This the deadly patterns here, so this must be blue. This 2x2 area can't be all blue, so this is green. This is doubled, but it still could be doubled here. This cannot be 8. It could be 1, 2, or 4 here still, so that's fine. This is green because it's its own value. This 2 by 2 area is green, so this must be blue. Same here. This must be blue. Deadly pattern, so this must be blue. Deadly pattern, this must be blue. So this is the same as this. Therefore, it cannot be 1 or 4. It's 2, 5, 7, 9. What next? Column 5, maybe? Let's see. 2, 3, 5, 7, 9. 2, 3, 5, 7, 9. So if it could be the same values, 2, 3, 5, 7, 9. It could be halved. 2 could be 1, 4, or doubled. So this is 1, 4, 6. So this could be anything, essentially. This can't be 3 or 5. So this can't be 5 here, then. Since this can't be... well, it couldn't be 3 anyways, so that's fine. 7 and 9 cannot be consecutive with 8, so this is 2, 3, or 5. Therefore, in column 5, 7 and 9 have to be here in box 8. That means 7 and 9 cannot be in the rest of the box. Actually, we have a 2, 7, 9 pair here, so we already knew that. Interesting. These are all 1, 2, 4, 6, and 7, 9 in columns 3 and 4. Because we're missing the same 3, 5, and 8. That's interesting. 7 and 9 cannot be consecutive with 8, so this can't be 7 or 9. 3 can't be consecutive with 2 or 4. Remaining digits of column 6. That's a lot. 1, 3, 4, 5, 6, and 8. 8 cannot be here, so this is 1, 3, 4, 5, 6, and 8 here. This is in a ratio with this, so it's 1, 3, 4, 5, 6, or it could be doubled or half. 4 cannot be here because of the 4 in the column. This cannot be 2 or 3. If it's 2 or 3, it would necessarily be consecutive with this digit. Right? If this is 2, that makes that 3, and that's consecutive. If this is 3, that makes that 2, so that's consecutive. So this is 5. Which means 5 cannot be here, 5 cannot be here. So 5 and 8 are both here. This is 5. Therefore, this can't be 5 here. If it's 1, it could be with 2. If it's 1 or 1. 3 could be with 3 or 6. 4 could be with 2 or 8. Can't be 8 because of the 8 in the row. And 6 could be with 3 or 6. So this is 1, 2, 3, or 6 here. 5 cannot be consecutive with 4 or 6, so this can't be 4 or 6. This can't be 4 or 6. That means where are the 7 and 9 in box 5? It has to be here and here. So these must be specifically 7 and 9. And they have to be the same shading. So this is same shading. This is same shading. We don't know if it's different, whatever. But 1 and 3, 1 can be with 1 and 2, 3 can be with 3 and 6, so that's fine there. We have a 7, 9, 7, 9 pair. This cannot be 7 or 9. We already knew that, actually. These are the same shading. What else do we have? 8 obviously can't be there. Okay. What about row 6? That's 1, 2, 3, 4, 5, 6, 8. 2, 3, 4, 5, 6, 8. This can't be 1 or 4. This can't be 6. I'm looking just at the columns or 2. This can't be 4. This can't be 3 or 8. This can't be 1 or 6. Okay, so this matches this. So it could be obviously the same digits, 1, 2, 3, 5, 6, 8, but it can't be 3 or 8. 1 could be 1 or 2. 2 could be 2, 1, or 4. 3 could be 3 or 6. 5 could be 5. 6 could be 6 or 3, but 3 can't be here. 8 can be 4 only. So those are the possibilities there. What about this digit? Can be 1, 2, no 3, 4, no 5, 6, 7, or 9. So correspondingly, 1, 2, 4, 6, 7, 9, no 1 or 6 are possible. So if it's 1, it could be with 1 or 2, but 1 can't be there. 2 can be with 1, 2, or 1, 2, or 4, but 1 can't be there. 4 can be with 2 or 8. 6 can be with 6 or 3. So those are all possible. What about these? This matches here. So 1, 3, 4, 5, 6, and 8. But 4 cannot be here. Also 1, 3, 4, 5, 6, and 8. But 4 cannot be here. 1 can match with 2 and 1. 3 can match with 3 and 6, already there. 4 can match with 2. 2 can there's no 2 here. So 4 can match with 1, 2, and 8. 5 can match with 5. 6 can match with 6 or 3, which is fine. 8 can be matched with 8. This can't be 5 because it would be consecutive with 4 or 6, either one. So this can't be 5 here. This can't be 5 for the same reasoning. Okay, 5 is one of these two. So 5 is here. Well, this can't be 5. That doesn't really help. And 5 is here, that would have to be 5, so this couldn't be 5. But that's not helpful. 8 cannot be here again, because 8 would be consecutive with 7 or 9. So this cannot be 7, 9, 2, 6, or 8. So it's 1, 3, 4, 5. 1, 3, 4, 5. So if this were 5, this would have to be 5 here, so that doesn't work. 1 can be with 1 or 2. That's fine. 3 can be with 6. This cannot be 7 or 9. So it's 1, 2, 4, 6. One of these is 2 or 3. We're not sure which. Oh, this is doubled. So since this is okay, this is also green because of the 2x2 area. This is also green because of the 2x2 area. Oh, that's interesting. This is doubled. So this must be doubled here because this can only be 1 or 3. Why couldn't it be? Oh, 6 can't be next to 5. And 2 can't be here because of 2 in the column. So this has to be 1 or 3 here also, and this is doubled. So this is the same digit. Which means this is a cross blue, so this must be blue, which makes this green, because this 2x2 area would be all blue otherwise. This 2x2 area is all green so far, so this is blue. This cross blue means this is blue. Since this is blue, this is green and green, so these must match. So it cannot. So these have to match. It cannot be 1 or 6 here. And this can't be 3 or 8. This 2x2 area is all blue. Actually, we already knew this had to be green. Interesting. This is blue. This is a 2x2 blue, so this must be blue here. This green has to exit out, so this has to be green. So these are all green. We don't know about these. So this is the other color. We don't know. Then pink. Cannot be the same color, obviously. This is this cannot be 7 or 9, so this can't be 7 or 9 here. It still could be double. You could double here and then match that. Um, hmm. Okay. These are doubled and the same. These are doubled and the same. We don't know what this shading is. This could be 2 still. This can't be 8 because it'd be next to 7 and 9. So we have a 1, 3, 4, 6 quadruplet, which eliminates 1, 3, 4, 6 in the rest of the column. So this can't be 1, 3, 4, 6. This is a 5, 8 pair. So that forces this to be 5 or 8. Cannot be 4 anymore because of the 4 in the column. So these must match. So these are green. So this is green. The blue has to go out, so it has to go out this way. Therefore, these must match. This is a 2 by 2 area, which is all blue so far, so this must be green. You have a cross green, so this must be green. This is a 2 by 2 area, so that's blue. This blue must go out, so it has to go out that way. This is the same as that cell. This must be the same as that cell. So this can't be 4. Oops. This can't be 4. This can't be 2, 5, or 8. Wait, no. Oops, wait. Apologies, I messed up. Okay, so this matches here. Right. So this is 5 or 8. Okay, so that doesn't give us anything there. Never mind. So this is 5 or 8. That matches here. Okay. I was gonna say that was kind of weird, but yeah. So this has to be 1, 3, 4, 6. 1 could be with 1 or 2. 3 could be with 3 or 6. This can't be 5 though anymore. 4 would have to be with 8, and 6 could be with 6 or 3 here. Okay, so this is a 5, 8 pair, because again, it can't be next to a 7, 9. Okay, so we do not have that information there then. Well, this could be blue here. Hmm. Okay. 5 cannot be here because it would be next to 4 and 6. Okay, 5 cannot be here because if this were one of these two is 5, right? This can't be 5 because it'd be next to 6. This can't be 5 because it can't be 5 here. And the 5 in the row. So 5 is either here, which would force this to be 5, and that can't be 5. Or it's here, which means that can't be 5. So this can never be 5. What else do we have? Okay. If this were 2, say this was 2. Okay, say this wasn't 2. Then this has to be a 2-4 pair. Therefore, this... So if this is not 2, this is 2-4 here. So this would be 1 or 6. If this is not 2-4, where is the 2 going to be? It has to be here. So this can never be 4. 4 has to be one of these two, which means this can never be 4 here. So this is 1, 3, or 6. 4 has to be one of these two. If it's 1, it can be 1 or 2. 3, 6 can be with 3 or 6. 8 can never be here. So this is 1, 2, 3, or 6 here. Okay. This could still be 1, 2, 4, or 6 anyways, though. Um... Hmm. Hmm. 2 cannot be here or here. Because if 2 is here, it's next to a 1 or 3, which is consecutive with. So these can't be 2. Where is the 2 in row 3 now? It has to be here. So this is 2, which means this can't be 2. This can't be 2, so it can't match there. Well, it could be. No, they're the same. So these are the same digits, so it's 4, 7, or 9. Oh, and it must match one of these 3. It can't be this one, though, so it's one of these 2. Okay. This is 2. One of these is 5. That means one of these is 5. That means, actually, yeah. If this is 5, this has to be 5. Otherwise, this is 5. So 5 cannot be in the rest of the column. So this can't be 5 here. We already knew that, though. Anyways. Hmm. This can't be 2 because it's next to a 1, 3. And 2 cannot be here anymore, so 2 must be one of these two digits, which means this cannot be 2. This is 3 and 6. There we go. So this can't be 6 here. This 3 eliminates 3 here. This is 1, which forces that to be 1 to be the same. This can't be 1, 3, or 6, so this is 4. This must be 2. So this has to be 2, 1, or 4 here. We're not sure. This can't be 1. This can't be 1, though. Oh, this is 2 as the same digit, so this must be 2 as the same digit then also. So this is green, which means this cannot be, this has to be blue. So these are blue. That forces this to be green because of the 2 by 2 area. We have the deadly diagonal, so this must not be blue. This is green. So these are blue. These can't be 3 or 6 or 1. So it's 2 or 8, which must be with 1, 2, or 4 here. And this is doubled, so it cannot be 8. So this must be 2. That makes this 1. This 2 eliminates 2 here, so this is 4, which makes this 2. Therefore, this is 2 doubled. That connects this way. This is a 2 by 2 area, which is all blue, so this is green. That matches that. Actually, yeah, this had to match that. Not necessarily. I guess it could have been... No, it did have to match it. Never mind. So this had to be green anyways. This green means this has to be green here. That's 1 and 3. This must match with 1 and 3 here. It cannot. This is 3 and 3. These are both green. Therefore, this must be blue. Blue must connect, so this is blue here. These can't be 4. So this becomes 7, 9, 7, 9, 7, 9, which is the same as that 7, 9, which means it cannot be the same as this. This has to be the same 7, 9 here. So these are all the same. I guess we'll mark these as A. This is A, this is B, this is A. Cannot be here, cannot be here. Can't be here. This is B. So this is A, which makes this A. So B has to be one of these two. We don't know. Okay, so this is B here. Okay. We need to connect, so it's either connecting this way or this way. Okay, so this can't be 2 remaining in column 1, or column 3. Can't be 2 here because of the 2 in the row. So this is single. So it could be single here. Okay. If this is blue, it has to connect. We have a 5, 7, 9 triplet actually in column 8, which eliminates 5, 7, and 9 the rest of the column. We need 1 and 6 left. 1 can't be next to 2, so this must be 6. This is 1. Where's the 6 remaining? Column 7 can't be here because of the 6 in the box. Can't be here because of the 6 in the box. These are filled out, so this is 6. 4 cannot be next to 5, so this is 8. This can't be 2, 3, 6, or 8, so this is 5. This can't be 3, 4, so this is 1. That makes this a 1 also, so these are both green. Because this was already green. Therefore, this 2x2 area forces that to be blue. This blue must connect here. This 2x2 area forces this to be blue. And we just now do normal Sudoku with the non-consecutiveness thrown in. So this can't be 6. We're looking for 3, 5, 7, 9. 3 cannot be here. Where's the 3 in this box then? It has to be here. So this is 3. The remaining digits in row 5 are 4 and 8. This can't be 4, so this must be 8, which makes this 4 because of the 4 in the column. We have 3, 6, 7, 9 remaining. 3 cannot be next to here. Where's the 3 in box 4? It must be here. So this is 3. This can't be 6. This is 7 or 9. So this must be 6 here. 6 cannot be consecutive with 7. So this is 9, which makes all the B's 7. So these are 7, and all the A's are 9. Okay. That means this can't be 9. This is 5 or 7. This can't be 9. It's 5 or 7. Okay, this cannot be 9 anymore. This can't be 1. This can't be 7 or 6. It's a 4-9 pair here. 9 eliminates 9 here. So this must be 4, which makes this 9. This 9 eliminates 9 here, so it's 7 and 9. This can't be 4. This can't be 1. Where is the 1 in box 8? It must be here. 2 cannot be next to it, so 2 cannot be here or here. Where is the 2? It has to be here. This 3 eliminates 3 here, so that's 7. We should have 8 2s now. We do. We know where the last 2 has to be. It has to be here. 1s. We should have all the 1s. 3s. We have 8 3s. We know where the last 3 has to be. It has to be here. 4s. We should have... We don't have 8 4s. We don't know where those are. 5s. 5s are kind of restricted to. This is a 5 7 pair. This is 5 7 or 8. We don't know what that is. Okay, in column 9, we have, what, 4, 5, and 7 remaining. In column 1, we have 6 and 7 remaining. And in column 2, we have 5 and 8 remaining. Okay, well, we have in row 7, we have a 5, 8, 5, 8 pair, which eliminates 5 and 8 from the rest of the row, so this can't be 5. Also, this 4 is here, and it can't be next to a 5. So this is 8, which forces this to be 5, and the 7 couldn't be next to a 5. So this 5 eliminates 5 here, so that's 8. Therefore, this must match here, and that's an 8. 8 cannot be next to 7, so this can't be 7 or 8. This is 5, which forces this to be 7, 7, 5, 5. That means, and 7 cannot be next to 8, so this is 4. This is 7. 4 eliminates 4 here, so it's 6 and 4. 8 eliminates 8 here, so it's 5. 6 eliminates 6 here, so it's 7. That makes this a 6. Wow. Apologies. That took way too long. I just completely ignored the non-consecutive factor. And it was interesting trying to go through and trying to figure out the other stuff without the non-consecutive restriction. But obviously it was doomed to failure to do that, so not the best way of going about things. But yeah, hopefully you went down the path of figuring out, oh, it has to be non-consecutive, and then you didn't make the mistake of eliminating the twos. I don't know. That was weird. I should have just eliminated obviously I just should have eliminated the ones. I don't know why I didn't, but anyways, sometimes that happens. Yeah, lately I've been a little bit just sort of out of it, so surprisingly I'm not so upset with this. I don't know why. Just completely ignoring one of the rules for some reason it's fine. You know, I tried to do it the very hard way. Well, actually, the impossible way. But yeah, reading the rules is good. Reading the rules is good, and refreshing your mind of the rules, and then also not completely screwing up something. That's also good. Anyways, I hope you enjoyed this solve. Maybe you enjoyed my struggling through this of just not reading the rules or just randomly eliminating a 1. And hopefully you enjoyed it, though, whether you enjoyed that part or some other aspect. And I'll see you next time on Frank Puzzles. Take care.